So we have seen the properties of matter as physical property and chemical property. Now how to measure the properties of matter, that we are going to see. See, physical properties should be measured quantitatively. All the physical properties should be measured quantitatively. We have an international committee for weight and measures. They have recommended the usage of International System of Units. In short, it is called as SI units. Okay. So, International Committee of Weight and Measures, they have recommended the usage of International System of Units. What is that in short called? SI units. Okay. Now, we will be seeing some of the physical properties and what is the symbol which is used to indicate the physical property. So, these are the physical properties. Length. How will you measure length? By means of meter. Mass can be measured by means of kilogram. Time can be measured in the form of seconds. Temperature is measured in Kelvin scale. Amount of a particular substance is measured in terms of mole. Electric current is measured in terms of amperes. And intensity is measured in terms of candela. What is this two will be, I think, new for you. Amount of substance is mole and intensity of a substance is measured in terms of candela. Now we will be seeing these, or we will be seeing the physical properties one by one. Mass of a substance. See, mass, when I am going to indicate mass is going to denote the amount of a particular substance. Mass is indicating the amount of a particular substance. And your mass will be remaining constant throughout. How will you measure the mass of a substance? Mass of a substance can be measured in terms of analytical balance. What is the SI unit of mass? It is kilogram, right? The SI unit of mass is kilogram. For smaller units, I will be using the term grams. Second physical property is weight. Weight is nothing but force exerted on an object by the gravitational force. By the gravity is called as weight. What is weight, children? Force exerted by an object on the object by gravity. By the gravitational force is called as weight. Weight will not be constant. It will be changing from one place to another place. For example, in Earth, we will be experiencing gravitational force. Say, for example, my weight is 60 kg. If I go to moon, there is no gravitational force. So, what is weight actually? Force exerted on the object by gravity. Since no gravitational force, the weight of the object will be 1/6 in the moon. Done. Now, how will you measure the weight of a particular substance? Weight of a particular substance will be measured in terms of spring balance, and SI unit of weight is Newton. What is the SI unit of weight? It is nothing but Newton. Moving to the third physical property, volume. What is volume? Volume is nothing but the space occupied by a substance is called as volume. Volume is the space occupied by a substance. What is the SI unit of volume? It is meter cube. Suppose I want to indicate a smaller volume, then I will be using decimeter cube. dm³ will be used to indicate smaller volume of the substances. How will you measure the volume of a substance? You will be seeing burette. You have seen burette and pipette and all in the laboratory. So using burette, pipette, graduated cylinders, then cylindrical flask where measurement will be written. So these are the means by which you can measure the volume of a substance. Now what is molar volume? What is molar volume? Molar volume is nothing but volume exerted by 1 mole of a substance at standard conditions of temperature and pressure. This is a constant value. It is 22.4. What is molar volume? Volume exerted by 1 mole of a substance at standard conditions of temperature and pressure is a constant value. It is 22.4 liters. Next, density. What is density? Density is nothing but mass per unit volume. And what is the SI unit of density? It is kilogram per meter cube. So, what is the use of measuring density? When I measure density, I will be knowing how closely packed the particles are. Okay. So, we have seen almost 4 physical properties here. We saw mass, we saw weight, then we saw volume, then we saw density. Next, we will be seeing temperature. The last physical property will be temperature. Okay. So, what is the definition for temperature? Temperature refers to the total heat content of a substance. Okay. I have taken a substance, the degree of hotness or the degree of heat by which the term which is used to measure the degree of heat of an object is called as temperature. So what is temperature? Temperature refers to the total heat content of a substance. There are three scales for measuring temperature: Celsius, Kelvin and Fahrenheit. Okay. Celsius can be measured in thermometer and the readings will be calibrated from 0 to 100 degrees Celsius. What about Fahrenheit? The calibration of reading will be 32 to 312 degrees. And you know how to convert Kelvin, how to convert Celsius to Kelvin? Just add 273 to Celsius scale, you will be getting Kelvin scale. How will you convert the Fahrenheit to Kelvin? The formula is 9 by 5 Celsius plus 32. So these are the ways by which your Kelvin can be converted to Celsius and Fahrenheit converted to Celsius. See, there is always a possibility of negative temperature in case of Celsius scale. Say for example minus degrees, minus 12, minus 13 like that. So negative temperature is possible in case of Celsius scale, while in Kelvin scale there is no any negative temperature. It always holds a positive value. Before I was explaining about 1 molar volume, in that I was telling you about STP. STP means standard conditions of temperature and pressure. What is that standard condition? Standard condition means pressure will be kept constant as 1 atmospheric pressure and temperature will be constant as 273 Kelvin. So this is called as standard conditions of temperature and pressure. So in chemistry we will be doing a lot in measuring. In the laboratory we will be taking measurement and we will be taking the weights of large number of chemicals. So in all those measurements there is a chance of uncertainty. So more the uncertainty in any measurement is going to infer me telling that there is less accuracy. More the uncertainty, less the accuracy. This is also a related term. So today we have seen all the physical properties of matter. So in the next session we will be seeing about scientific notation. Okay. Thank you children.